We're talking about graphing radical functions and transformations of radical functions. And for this, we want to graph the function, then state the domain and range. And the first thing we want to start with is normally we're thinking about numbers that work within the radical, and we pick like 0, 1, and 4. But in this case, if we substitute in 0 into this equation, that's not going to work out well for us. So if we substitute 0 in, we get 0 minus 3, and we take the square root. So if we just examine the radical, 0 minus 3, that ends up being the square root of negative 3. And in that case, the square root of negative 3, that is imaginary, so that's not going to be useful for us to graph very easily. So what we want to do is we want to really focus and make sure that whatever we substitute into for the x is going to make sure that this radical works out very nicely for us. So we're still thinking of 0, 1, and 4, but it has to be those things after we subtract 3 from it. So we can write down the equation. We have 1/2, and then we're going to take the square root, and we'll subtract 3, and then we'll add 1. And then the same thing, we'll do 1/2, and then we'll take the square root, and we'll minus 3, and then we'll add 1, and then we'll take 1/2, and we'll take the square root, and we'll subtract 3, and we'll add 1. So whatever we substitute in, it's going to have to get us equal to, we want this, whatever's under the radical in this case, we want this to be equal to 0. Then for this one, we want this one to be equal to 1. And for this, we want the whatever's under the radical to be equal to 4. So what do we have to substitute in under the radical in order to get it equal to 0? Well, in this case, it has to be 3. So we're going to substitute 3 in. 3 minus 3, that's 0. Multiply by 1/2, that's still 0, plus 1, and we get 1. How can we make what's underneath the radical be equal to 1? Well, we need to be 1 bigger than this, so we're going to substitute in 4. 4 minus 3 is 1. The square root of 1 is still 1, times 1/2. 1 times 1/2 is 1/2, plus 1, that is 3/2. Now we want it to be 4. We need it to be 4 bigger than negative 3. So in this case, we need it to be 7. We're going to substitute 7 in. 7 minus 3 is 4. The square root of 4 is 2. Times 1/2 is 1. Plus 1 is 2. So we get our points that we're going to graph. We substitute in 3, 4, and 7. So 3, 4, and 7. And we got out 1, 3/2, and 2. So we go ahead and graph it, and we need to get all the way to 7. So we're going to have to say that we're going from negative 10 to 10, and we can stick with counting by ones on these x's. So 3, 1. So 3, 1. 4, 4, 3/2. 4, 3/2. And 7, 2. There's 6, 7, 2. The big thing here is we pay attention to is where we start from, and we start at 3, 1. So that's going to help us pick out what our domain and range are. So the domain has to be, we're limited by the domain by what's underneath this radical here. So the smallest value we can plug in is 3. If we plug in anything smaller than that, we get a negative under the radical, and then we're not going to be able to graph that. So 3 is the smallest value, and that is included. And when we're going to go to infinity, and that is not included, another way that we can do it in set builder is we can say x is greater than or equal to 3. And we can also do our range. Our range here is going to start at the lowest value, which is 1, and that 1 is included. And then that is going to go to infinity. And we can do that in set builder. We can say y is greater than or equal to 1.